Alright, hi everyone. Welcome to Summit Online on CI/CD at Scale, Best Practices with AWS DevOps Service. My name is Yang Meng and I'm a Solutions Architect here with AWS. It is amazing to see how DevOps and CI/CD has been gaining momentum over the years. Today, almost every organization wants to be more productive and more agile. That's why they're looking to bridge the silos between dev and ops. Hence what we call as DevOps, right? So now DevOps is not a product. It's a culture, a movement, or even a transformation for many companies. I'll be speaking for the next 15 minutes to give a broad view on how do we view DevOps and also introduce some best practices that help organizations deliver faster and more reliable updates to their customers. Later on, I'll be inviting Martin and Arshad from Electrify Asia, who will be speaking more about how DevOps have helped to enable their teams to be more productive. They even built some of the DevOps process into an Alexa skill and will demonstrate how they can simply use their voice to control their pipelines live here today. So a quick overview on what I'll be covering. I'll start off with explaining what DevOps means to us and bring focus into three key best practices in DevOps, mainly pipeline automation, safe deployments, and repeatable infrastructure changes. I will then invite Electrify Asia to tell you how they run DevOps on AWS. Let's start by talking about DevOps. In Amazon, here's what we think. DevOps is made up of three key aspects, right? Culture, practices, and tools. So we believe that the combination of these help to increase an organization's ability to deliver applications and services at high velocity and at scale. Culture, right? Culture is made up of a few things that involves mainly the mindset, right? For leadership, what is the strategy, mission, and vision of the top management? Do they value what it means to be agile? In the organization, is there a learning culture in place? Does everyone understand what it means to develop modern applications? Now, the individuals, are they stuck to the old traditional mindsets of software engineering? And practices. These are mainly processes in the organization. Do you practice loosely coupled architectures? Do you do small but frequent deployments to reduce your risk of application defects? Do you enforce good coding practices? Does the organization follow microservices patterns, and so on and so forth? Now, tools. Having the right culture and practices is still not enough without the tools to ensure that the teams are productive. Yeah, sure, we can do smaller, frequent deployments, but doing so manually is not scalable, right? You need tools to automate the process. Now, let's talk about what it means to have DevOps at scale, right? A typical small development shop may have a simple release process like this, right? A source repository where they pull the application code from, build the application with an artifacts and output, put it through pre-production environment with some unit tests, and finally push it to production. As you scale, you probably have a more complex application with a larger team. Now, perhaps more QA testers to write more test cases and put the application through a more rigorous testing. You may also deploy to a variety of deployment destinations, right? For example, on AWS, we have like EC2, Lambda, containers, or beanstalks. You see that now it becomes a more complex architecture, and you want to think of introducing infrastructure as code, abstracting configuration and maintaining a base image, and so on. And then you might think of a global deployment, right? Across regions. You need to consider how to ensure your applications function reliably, highly available, and secure at the same time. So at scale, you find that you are faced with a huge operational challenge. So I'll be highlighting three best practices for CI/CD that we believe are crucial to running DevOps at scale. Firstly, right, pipeline automation. So this is a typical release process stages and similar to the one that I've shown earlier. At each stage here, there are some practices to be in place. The best practice here is to automate everything, right? Leave no room for human intervention, because when there is a human involved, there will always bound to have an error. So on AWS, we provide several tools that can help to automate most of these practices. So as you can see here, these are the AWS code services that can be used for automation, right? So we have a code pipeline, code build, code deploy. So code pipeline is like the glue here that helps to gel all of these services together, right? The reason we have different tools for different stages is because they are purpose-built and are fully customizable, just like Lego blocks, right? So you can use each of these services individually. Like for example, you can swap out code commit with GitHub, or simply use the whole suite to build your pipeline. But of course, Code pipeline is a fully managed service, right? You don't need to run or manage any servers at all. So you can automate which stage comes first, perform builds or execute tests in parallel, or add approval stages and notifications into your pipeline. So the key benefit of using Code Pipeline is that it has very wide integration with not just AWS services, but also other third-party tools. So you can trigger things like a third-party load test or even integrate it with Jenkins. So as for the supported sources, so you can trigger the pipeline automatically from a code change from code commit, GitHub, or Bitbucket. So this is something new from December 2019. Bitbucket users can now integrate with Code Pipeline, including using IAM for fine-grained permission management. So Code Pipeline also supports S3, so you can automate the pipeline to execute whenever an artifact is dropped into one of your S3 buckets. So if you're using containers, changes in your container tags in ECR can also trigger your pipeline. So you can integrate with Event Bridge as well, our serverless event bus to schedule builds, kind of like setting up a serverless cron job, right? So you can also use custom webhooks as well to call Code Pipeline to tell it to start a new build. So you will see in our demo later how we can use custom webhooks to trigger Alexa. In terms of deployment targets, there are quite a handful. So we have Code Deploy, integrated across EC2, containers, and serverless as well. So looking back at our release process, right, the goal of continuous integration is to keep changes as small as possible and build as often as you can. So you want to automate this process of kicking off a new build whenever new code is checked in without any developer involvement. By automating your builds, you ensure that each build is repeatable and exactly the same each time. The post-build stage could also involve running a series of tests to ensure that defects are minimized. So CodeBuild is a service that can help to compile your code, run tests, and produce software packages. It is also a fully managed service, meaning that you don't have to provision any servers. So it helps to run your build process effectively at scale in the cloud. It processes each build immediately and run separate builds concurrently, which means that you will never need to wait for build capacity to be free. So CodeBuild uses a file called buildspec.yaml, right? So it's a YAML file, which is like a sequence of commands that you can input to instruct CodeBuild to run. So these commands are organized into several phases of the build. So in this case, we are building a Java application and using commands like maven install. So you can also call AWS CLI commands to retrieve credential information from secret manager and add them into the application config. So remember that version 0.1 build commands are run in separate shells, so environments in memory are not carried to the next phase. So use version 0.2 to easily pass down environment variables. So this is usually a gotcha that most people often encounter. So something new from November 2019, CodeBuild added support for test reporting. So you can now view detailed results, trends, and history for the tests executed as long as the framework supports the test format. You just need to add this section here and specify a location for the report. Now the test report will provide a breakdown of each unit test, status of the run, how long it took, and any error logs. Very useful for developers to use this to quickly debug any defects found. So now let's shift the focus into deployments, in fact like safe deployments. So if you look at in a continuous deployment, the goal is to automate the deployment of your artifact into production without any impact to actual users. So if your changes can be applied seamlessly into production automatically, you can reduce your change lead time and therefore deploy more frequently. So here we have Code Deploy, which is a service to help automate deployments in EC2 instances, ECS containers, Lambda, and even on-premise servers as well. So you can use Code Deploy to avoid downtime by taking care of the logic behind picking which instance to update, stopping new connections from coming to your old instances, and even draining out existing traffic. So Code Deploy can also be configured to watch for the health of the deployment and handle rolling back of the change quickly. So Code Deploy uses a file called appspec.yaml, which is similar to buildspec but allows you to provide commands to get your application started on the deployed targets. So this is an example of how an xspec file will look like for an EC2 deployment. Right? So you can see here that the lifecycle hooks are fully customizable, so you can run commands from there, even things like secret manager, right, to load in environment variables, or to even start or stop servers, or even trigger your Ansible playbook from here. So you can also configure your deployment speed and deployment group as well. So you can customize these based on the appetite for risk. Like if, for example, if you're deploying to production, you might want to do this one at a time so that if there are any issues, you can quickly roll back the change and reduce the blast radius that you have in your live environment. So you can also target your deployments using groups, right? So by using tag values or auto-scaling groups, Code Deploy can help you figure out and perform the deployment to the targets accordingly. Now let's take a look at how blue-green deployment is carried out in ECS to ensure zero downtime. Right? So you have an ALB that points to an HTTPS listener and a target group with a set of tasks. So this older version of code is what we usually call the blue group. In a blue-green deployment, you then have a green target group and a test traffic listener on a different port, but with traffic pointing to the blue target group. When the deployment starts, Code Deploy creates a new task set. So at this point, note that no traffic is actually going into the green task. So once it has come up and become stable, Code Deploy will shift the test traffic from the blue target group to the green target group. And at this point, live users still do not have access to the green task, and it's the perfect opportunity to run any validation tests on the new application version. So in any event that there is a breaking change and the lifecycle hook reports a failure, Code Deploy will simply spin down this new task so production traffic is never impacted by this breaking change. So if the hook is successful, Code Deploy will shift production traffic to the green target group. Now at this point, you can have Code Deploy monitor alarms for any issues. So if any alarm triggers, it is easy and fast for Code Deploy to roll back to the blue tasks as they have not been removed yet. Right? So blue tasks will actually wait out based on the termination wait time, which you can configure. So once the termination wait time is reached, the blue task will be teared down. As for Lambda deployments, a blue-green deployment is done through a Lambda weighted alias. So let's say we deploy a new version of Lambda function with Code Deploy. If you have selected a canary deployment, it will shift 10% of the traffic for 10 minutes before shifting the rest. Now during the 10 minutes, it will constantly validate that it is working. If the hook fails or the CloudWatch alarm sounds, it will simply just roll back the traffic so that there's minimal impact to users in the live environment. If there were no issues encountered, it will shift 100% of the traffic over. Cool. So let's now talk about repeatable infrastructure changes. Referring back to what we spoke about DevOps at scale, very often when we talk about CI/CD, it's about how the application moves between the different stages and how it gets deployed to production. But in fact, there are actually so much happening around the application infrastructure, right? Take, for example, just one cluster of EC2 instances. Think about the IAM roles required to be in place, the security groups, the load balancers, health checks, pipeline configuration, and so much more. If you want to quickly replicate this infrastructure across multiple regions in a repeatable and consistent manner, how are we going to do this? Right, so this is where infrastructure as code makes sense. The idea is to look at infrastructure just like looking at your code. So you can also use the same tools to structure and track changes just like how you version control your application code. You can also create an almost identical production environment as a staging environment for testing. So if you have been using CloudFormation to write your infrastructure as code and you really hated the curly braces in JSON like me and all the white spaces in YAML, I'm a YAML person, so you might want to check out like AWS Cloud Development Kit or CDK, right? So CDK is an open source framework which allows you to define your cloud infrastructure using TypeScript, Python, Java, and .NET. Under the hood, CDK actually synthesizes your code into CloudFormation templates, right? So it supports all the CloudFormation resource types and provides a library of high-level resource types that AWS best practices built in by default. So for example, if you look at this sample CDK template written in TypeScript, so in the line that is highlighted, in just one line of code, it helps to provision a VPC that comes with a subnet, security group, internet gateway, net gateway, and route tables, all according to AWS best practices. So in the line below, this creates an ECS cluster that runs on Fargate that comes with the ALB, listener, rule, target group, and Route 53 alias record as an optional. With just 22 lines of code, it generated over 400 lines of CloudFormation syntax. Now, can you imagine if you operate at a large scale with tens or hundreds or even thousands of AWS resources? How many lines of CloudFormation code that do you need to write? So by using AWS CDK, you can build your infrastructure in your favorite IDE, using your favorite programming language, and because it's just like writing application code, something that all developers like us like. So you get productivity benefits like code completion and inline documentation, which makes it faster to model your infrastructure. And now I'd like to pass the time to Martin and Arshad from Electrify Asia, who will tell us how they have used our code services in their environment.
Hi, my name is Martin. I'm CEO of Electrify. Electrify is a startup about 3 years old, and we started by building a transactive energy platform for energy trading across a citywide grid. In fact, we've built a peer-to-peer platform that allows you to do that. We've been presenting this platform to grid and utility operators across the region. We've talked to people in Malaysia, in Thailand, and even Singapore. In fact, in Singapore, we're going to a full commercial pilot in the next few months. So you can imagine the amount of work we need to do to integrate with AWS, who's been a partner with us for the last 2 years. The amount of work is immense. And we're very, very glad to say that we've worked out some nice, quick modes of automation. And I'll let Arshad tell you a lot more about it right now.
Thank you, Martin. My name is Arshad, Senior DevOps Engineer with Electrify Asia. So I'm going to talk about what are the challenges we had and how we rectified with using AWS services. Lacking a standard CI/CD platform, we were using a Jenkins server to do the deployment for all the application and this services. One of the main challenges was a proper CI/CD platform. Our app stack is running on multiple languages such as Golang, JS, Python, and some PHP as well. Setting up a CI process for each was not an easy task. More manual human interact workload for deployments. There are more human interactive manual tasks when we have to do deployments and executing post-build commands. There are more downtimes and hard to roll back the deployments. Highly vulnerable security issues such as trouble with keeping the secrets. As a best practice, we should not commit the DB and other configuration files to the repos. It is highly vulnerable. Once we created the container images, need to set up a separate scanner for scan the images, which is an extra effort. Trouble managing the infrastructure. Managing the infrastructure changes for deployment was a huge trouble. Hard to isolate the bottlenecks of the application, services, hence no proper observability. In the DevOps culture, observability taking a pivotal role, which is really important to integrate all these into a CI/CD setup. Without proper traces and logs, hard to identify the application bottlenecks. As we all know that AWS has 170 plus services and tools, much more to come. This is our Electrify stack and all the AWS services we are currently using. We are using all the developer tools and which helped us to satisfy requirements. Our application is data intensive service which needs services such as Redshift, data warehouse solutions. Postgres on Aurora helping us to scale our application when we need more replicas for run the application smoother. For analytic and for the data pipeline, Kinesis, Glue services are best solution we got from AWS. As I mentioned earlier, we had huge challenge maintaining the secrets DB credentials for the application. AWS Secret Manager made it easier and safer. We know that we have to deploy things faster, break things over and again. To make that process streamlined, we came up with this solution. We have deployed a fully automated pipeline, saved our cost and time. No more manual interaction as everything is fully automated. ECR is supporting inbuilt image scanning, hence we do not have to worry about the security side. Setting up an open source system such as Jenkins to build your code, you have to go through a lot, install all the plugins and configure. But AWS code build is really easy to use in a single file. You can write that you have to do and mention the required runtimes. AWS code build will do the needful. Deploying and setting up a Kubernetes cluster, it's not an easy task, but we can create a Kubernetes cluster within few minutes on EKS. Since we have using all AWS services, role-based permissions made the setup easy and more secure. All the RDS DB credentials are securely stored in AWS Secret Manager. Application can access securely. When it comes to observability, AWS Container Insight and CloudWatch made our life easier to monitor, observe the bottlenecks, and check errors, where we can improve our application to standard level. So this pipeline made our developers' life easier and no need to worry about the CI/CD. They can focus on their code instead. These tools help us to practice a good DevOps culture at Electrify. We didn't stop from only the pipeline, and we made it more interesting by integrating Alexa with our AWS code pipeline. Our application is running on multiple services. We thought, what if we can easily and fast deploy different versions of the application or services? We thought, okay, why don't we use a voice assistant? We developed a custom Alexa skill for our DevOps support, can call as a DevOps assistant. Maintaining the DevOps culture at Electrify is really important for us. This setup made our developers' life easier and really enjoyable while working with it. When we need to deploy versions, we just ask Alexa to do it. We have few intents developed, such as for deployments, check the pods, check the AWS resources, utilization. It's a demo time. So I'm going to show you how I'm going to do the deployments using the Amazon Echo device. So I have Amazon Echo device here. So in the screen, you can see the version 1 of the application. So we are going to do the deployment now. Alexa, open DevOps Assistant.
Welcome to the Electrify DevOps Assistant.
Deploy version 2.
Deployment has been initiated for version 2.
So let's go and see the console. So you see the deployment has been initiated. The deployment section is, you can see it's triggering. So let's wait. And once the deployment is completed, we will go to the next tab and we'll check the version 2 of the deployment. So the deployment is completed. So let's go to the version 2 tab. Okay, we'll refresh. Ta-da. So you can see the version 2 of the deployment. So this is how we are using day-to-day life, the Alexa, in our DevOps culture. So you can use the same thing in your organization as well. So you can try other services as, if you want to run the code build, you can just write Alexa skill and build your code. And if you want to get the notification as well, so you can get Alexa to get your build failure or successful notification. So let's assume you want to check your RDS performance, the connection count, maybe the CPU utilizations. So you can just write an Alexa app to get those done. And let's assume you want to run some scripts on your EC2 instances. So you can connect to the AWS System Manager to do that for you. So you can use whatever things in the AWS services and with the Alexa skill, because everything is running on Lambda, you can connect each other service together. So that's it from me. Thank you very much.
So thank you, Martin and Arshad, for showing us how you can build on AWS. So to gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts, attend our instructor-led classes by qualified AWS instructors, and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. Validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please, do take the time to fill out our survey and let us know what you think. Thank you very much.